Hi, everyone. Thank you for joining today's session. We're navigating the storm, and it's Falcosidekick's role in the everlasting Kubernetes cybersecurity battle. I'm joined today by my colleague, Tomas. We are both from the Falco project. Tomas, do you want to introduce yourself?
Yeah, sure. So my name is Thomas in French. I'm senior developer advocate at Cybersecurity, like Nigel. Before that, I was SRE and also Philips for something like almost 10 years now. I'm also CNCF ambassador, a Falco contributor, and the creator of Falcosidekick. Nigel will introduce you to you right now.
Yeah, so Tomas is the real mind behind this, as it shows on screen. He's the creator of the Falcosidekick project that we're going to show today. But yeah, like today, we're really talking about runtime security. And in case you're wondering what we mean by runtime, we mean when applications, containerized apps, when they're running, like actually active on a server, and anything around that, tools that are used, procedures used to secure those running apps, that's what I mean by runtime security. So it's pretty straightforward. Now, what is Falco and how does that work within runtime security? So Falco was a donated project to the Cloud Native Computing Foundation, or CNCF. Why does this matter? Well, it's quite interesting. So the CNCF are essentially a foundation, a charity, if you want to put it that way, that are responsible for ensuring a better progress when it comes to cloud native computing. Now, this isn't just down to security. This is down to all elements of making sure that applications are deployed appropriately and certain guardrails are created and that we can scale these applications appropriately. And Falco is the runtime detection component, you could say, of this cloud native ecosystem. So anything from the applications that run on a host, securing the host itself, but also the connections to the cloud tenant and securing the cluster that runs within that cloud tenant. This is what Falco serves as. So it's got over 100 million pull for Docker pulls on Docker Hub, and then you've got 6,000 people giving a nice little star on GitHub. So it's a very popular project, and the fact that it's recently graduated from the CNCF this year means that it has met all of the stringent checks that you can imagine from an open source project to prove that it is managed appropriately, that it has security audits performed, but also that it's evolving in line with the standards that are expected of the CNCF. So again, graduation is a fantastic seal of approval for the Project Falco. So you know that when attending this session, you're not hearing about some kind of fringe open source theoretical novel technology, but rather you're talking about something that has met the requirements to run in production in some of the largest cloud environments. So with that, how are we monitoring all of this runtime activity? And Falco is designed for Linux systems. So how this works is you have a kernel probe or an eBPF probe. We'll come back to that in a short while. But this collects system calls from the actual Linux kernel itself. So by collecting system calls, like imagine this, every time a file is created, deleted, anytime you make any modification on a system call is triggered that's associated with that activity. And that's really from the lowest level of the system. The kernel operates below the operating system. So below the user level, you have this kernel, and that's the brain of the machine. So by collecting and interpreting those system calls, we can monitor process activity, network activity, all sorts of activity, even down to IO activity. So what we're trying to show is that with Falco, we have this interconnected use case to look at in real time, but also, across different context, what's going on at the operating system level, at orchestration layers like Kubernetes, which is responsible for deploying these containerized applications, but also monitoring the activity within those applications or processes themselves. So I mentioned briefly a second ago about eBPF. How we traditionally did this in Falco, how other applications would have done a similar idea if they were doing introspection of a kernel, is they put in a kernel probe. And kernel probes are great, right? Like they do everything you expect. You get all that deep visibility. Problem is, it's a piece of arbitrary code. And I guess where the industry saw a concern was if you were to introduce these arbitrary piece of code into the kernel, what if, for instance, it didn't perform as expected and something went wrong? It panicked. And that's a big concern, kernel panic. It's not something you see every day, but if it happened, you could break the system itself. So obviously that's undesirable. So eBBF came as this, it's called extended Berkeley packet filter, but it's really quite different from the Berkeley packet filter project, which was really just for packet handling in the system kernel. But eBBF can be used for a bunch of different use cases. Generally speaking, security monitoring, any kind of diagnostics, because it's able to retrieve data from the kernel. But how it's different is it's kind of like a little VM running within the kernel. And by running in this secure, isolated environment, there's no risk to stability or security. So again, those concepts of like kernel panic and the likes don't really apply when we talk about eBBF. So you could argue the more secure, the better approach to moving forward with the project. And it uses this, what we call core, compile once and then run everywhere, which is a cool concept. So here's the architecture on the highest possible level for Falco. And so you understand what we're talking about today. So we mentioned we're collecting system calls from the Linux kernel. So this is the event collection stage. And that can either be done through the kernel module or through the eBBF probe. Again, that's up to the end user. And there's going to be different cases for each. Like if you're on an older Linux system prior to the introduction of eBBF, then of course you're going to have to use the kernel module. But in certain distributions of Linux, let's say, or Kubernetes, they might be clamping down on you introducing kernel modules. And because they're on a later version, let's say Bottle Rocket or one of these optimized AMIs that you can use in the cloud, a specific distribution in the cloud of Kubernetes or of Linux, you might actually have to use eBBF in that scenario. So we're granting the user the flexibility, depending on their system build, how you're going to collect that event data. Then once we've collected the system call data, we then match it against a rule set. So these rules, again, Falco is open source. So the same logic, it then extends down to the rule set. We give you full flexibility to then define these rules. Is how you're going to match that event traffic. Like if we were to handle all system events, it's just far too much data. We're not a SIM, we're not handling all events and then just trying to build some kind of complex data lake. Instead, we're trying to say, build a complex rule structure. So let's say I want to look at outbound connections to a C2 server. So I would devise a rule. In the rule, I would have a list, which is another abstraction, and that would be my list of IP addresses. Then in my rule, I'd have some kind of macro, and this can be my Boolean logic, right? And or logic statements. And I would say something like define what is the context of an outbound connection. Like it has to be an event connection from the system kernel, but might have to have some other context to it. Like, is it an outbound connection from a container that wouldn't talk to a C2 server? Like that's unusual. So you define the context within the macro. You've listed all your list of IPs that are considered like C2 botnet IPs, and you put that in your list. And then the Falco rule is just this really clean YAML manifest that says what I want to detect on. We mentioned that in the conditions. So that's your list and your macro. And then we're going to have some output, which is just the extracted metadata context from the event. And that's giving us that rich visibility as to, well, what actually happened. So we can see the outbound IP from a source IP. We could see, for instance, what was the connection type? What was the user running that? We'll come to all this in a short while. But that is the logic behind rules. And Falco is very much a rules engine. Out of the box, without Falcosidekick, you can stream out certain alert outputs. So you can send it to a syslog if you want to send it to the SIM, or you can output this to a file if you just want kind of CSV output or something of your events. You can do STD out. There's a bunch of these different methods where you can send them to an external endpoint, like HTTP if it's going to be like a web hook to some other tool. So you want to get like automation alerting or something like that in your PagerDuty or something like that. So these are out of the box options, but they're limited in their scope. And that's where Falcosidekick comes into today. So before I talk about Sidekick, I do want to give some more context around the kind of the evolution of the project of Falco. So we talked about system calls and they are pretty amazing. Like we're handling full system visibility. So we can look at process activity, container activity, the host operating system activity. But by creating these kind of arbitrary gRPC plugins, like again, open source project, anyone can build their own plugins, but this is a way to like authenticate from a third-party data source and then stream those events to Falco where we can apply the same rules logic again. So we can handle stream of events from, okay, without authentication, I mean, you could do this on the same server as Kubernetes audit log. So Kubernetes as an orchestration tool has its own audit logging service. And these are called Kubernetes audit logs. So by handling those and streaming them through a plugin into Falco, you can now correlate the context of the system calls with the Kubernetes audit logs. So rather than just saying, I saw an unusual connection to a C2 server, now I can see an unusual connection to a C2 server, but rather than seeing it from a process ID, I know it's coming from a container, a pod name, within a network namespace in Kubernetes, it's associated with a deployment object within Kubernetes. So you can enrich the context and really have deeper visibility than you would have in kind of traditional EDR solutions. An alternative approach here at plugins is by streaming context from, say, for instance, AWS CloudTrail from your cloud provider. You could say, I have a container, but it's running in the cloud. And yes, I can monitor the container in the cloud from the kernel events, but correlating that against the context of the cloud provider, you get deeper context about, okay, well, I have a very complex cloud tenant. Can I troubleshoot this quicker? And by having the output with the additional context from the cloud provider, super powerful. Or just simply alerting on insecure behavior on the cloud provider altogether. And again, you can do that via CloudTrail. So having this plugin architecture means we continuously handle different sources from new, complex, different parts of your stack, and then we can build detection around it. So it's really at this point, cloud native detection and response, or at this point, we're just talking detection. So moving on, so far I've talked about rules, and you're probably thinking, what is a rule? So this is an example of the simplest rule I could possibly show on screen. So at the moment, you've got a rule name, and that's just an arbitrary string, and it's just saying terminal challenge container. The description is that additional context. It's describing what is being said in the rule. So in this case, we know it's a shell that's been spawned and is specific to a container. Now, that doesn't do anything in itself. That's just something we'll see if it's triggered. The conditions is really the powerhouse here. So I mentioned earlier about defining macros and lists. Like a macro could be, how do we define what our spawn process is? And like, how do we know what is a container? And we also want to know what are those shell processes. There might be different shell processes that are defined. So you create the macros, they handle all the complexity. And then by just saying, I need a spawn process and its container and it's a shell process, that is a consistent string, like not a string, but a consistent statement that you don't need to modify often or ever, because the context that needs to be modified if we're trying to update this over time is within those macros. So the rule stays consistent. It's not this complex logic that you see in a single rule that would be hard to modify or hard to manage. The output then is really where Falco differs from other solutions. Because we're handling the system calls, well, we want to extract the metadata from those system call events. So we can say, for instance, a shell was spawned in a container. That's just the string. In the brackets then, within those parentheses, we're defining what are the fields that we've extracted from the system call. And we can extract, for instance, the user in this case, was it root or other? What was the login user ID? I could look at things like the shell process name. I can see parent-child process relationships. Was the explicit command that was executed, container ID, and so on. Like, I mean, realistically, if there's a system call being triggered in the kernel and it's relevant to the event, we can plug in that context into the output. And then really, we just have all this additional context. So for troubleshooting, it's better than just saying, we know there's a terminal shell and container. Well, I want all the surrounding context as well. And you can put that in within your output. So again, it's really important for operational response. Priorities are, again, I've said arbitrary a few times, but you can define the priority yourself. Like, that's not a fixed thing. But like, for instance, terminal shell and container, there might be a legitimate scenario why an employee is doing a terminal shell and container, but saying that it's not guaranteed to be an actual known threat. It's just an insecure behavior. So you might have priority warning because you're trying to let the admins or SRE know, okay, someone's terminal shell and container, that's unusual, but it's not absolutely a threat, versus someone running a crypto miner in a pod is totally, utterly has to be considered bad behavior as per company guidelines. Tags, again, arbitrary. You define your own tags, what you want to have in here. And these are really the supporting context. These can be used for filtering. We'll talk about all this later. But if you're trying to align with, for instance, like MITRE ATT&CK Framework from a threat detection response perspective, or with regulatory frameworks, so things like HIPAA, PCI, DSS, that kind of stuff, you can define those tags with those IDs. And it just means that when you go into Falcosidekick later, we have a nice report of what are the detections in line with what is our framework, so we can actually maintain compliance. And that's really powerful as well. So I talked about these rules. You might be wondering, okay, I'm not used to writing in YAML, or I don't know how to use this override context that you're mentioning here on the right side view. It's all very scary in the beginning. Well, it's not, in a way, because we provide, again, this number changes all the time, but we provide like 80 plus system rules out of the box. And for all those other plugins, whether it be Kubernetes Audit, AWS CloudTrail, whatever the source is, we generally speaking have a list of not supported, but stable rules associated with that. So things like privilege escalation, data exfiltration, it could be anything to do with executing shell into a container. We have rules for those activities. So the idea is once you install Falco and you start running some insecure behavior, probably we detect it out of the box. But we give you the flexibility to then define your own rules that monitor behavior that's unique to your own environment. So you might say, for instance, these pods should only talk to these pods over these IPs. And if we see TCP connections on ports that are not mentioned in that, allow list, then we see that as insecure behavior. But that's, of course, going to be unique to your organization. So here's what the output will look like. So we mentioned there about the shell into container. So it was this one. The description is the first thing you see. So it's a shell that's been spawned in a container. And we mentioned we just injected a bunch of these different fields into the output. So here we see a shell was spawned. It says notice, but it should actually be warning as per the priority here. But either way, once you have that, you'll see the priority, the name. Oh yeah, this is actually a slightly different one. This with an attached terminal on it. Then it will show you, here are the fields, either way they're colored in blue. They're the injected context that was extracted from the metadata of the system call. And again, if you have this correlated against Kubernetes context, then you can say not just that I see that there was a terminal behavior on a container ID, which is like an algorithmically generated ID, and that's subject to change regularly. Instead, then you also have the Kubernetes metadata context to say, well, I know it's in the namespace default. I know it's from this container name CNCF. And that way, even though container IDs tend to change, that metadata from Kubernetes, those abstractions, though they don't tend to change. So at least we know where this insecure behavior is happening, and I know how I can better get to the solution of the problem. So that's really cool, and that's what you'll see. But again, we'll show where limitations occur when you just have a stream of all this output data. So that's where Falcosidekick comes into place. Falcosidekick's one of the it's been there for a few years now, but this was a project that was added on later. And as you can see from the bottom left corner, it was introduced into the Falcosecurity project on GitHub. So it's another open source project, but it's an extension of the capabilities of Falco. And from here, what you can do is you connect your ecosystem. With 65 possible integrations and counting, you can use it for alerting, storage, streaming, chat notification tools, whatever it is. There's a dedicated, if it's functions as a service, if it's kind of, infrastructure as a service, this kind of stuff that you can say, based on an alert, we've detected an unusual thing in the cloud, then connect to the FAS service and then take action, automatically remediate that threat. And this is, again, a very cool addition to the project. Now, for today's session, we probably don't have enough time to go through response capabilities in Falcosidekick. We do have a session in 2 days' time in Vilnius, which we can go into further with the Talon response engine. But today we're going to focus on the UI element. So again, as you probably would have guessed, all the events are streamed through Falcosidekick, and Falcosidekick now is responsible for how it's going to push those events to those third-party endpoints. Or again, if it's something like Prometheus, you can actually pull metrics from Falcosidekick and then enrich that dashboard with all that additional context that's coming from Falco. So Falcosidekick is installed on the side of Falco, and then it handles all the responsibility of how we're going to get events to a third-party endpoint. Now, I'm going to focus on Sidekick UI. As you can see from the bottom left corner again, this is a separate module within the Falco security project. So you can use Falcosidekick UI as kind of a standalone thing with Falco, and you don't need to actually have to do all this other automation stuff if you don't want to. But Falcosidekick UI obviously came after a bit of community demand, if you want to put it that way, that it's great that Falco has such deep visibility, but I love to see this in a graphical user interface. I don't want to see it via terminal. I don't want to worry about sending it to third-party endpoints. I just need something quick that I can just, go port forward, access on local host on a specific port number. And from there, I have all this beautiful graphic UI to show me all the context. So rather than spending too much time on this part, we're going to quickly go into a demo. I think this is what probably everyone's going to benefit from. So now you see the full view of Falco, Falcosidekick, and the UI, whereby you have all the event sources, whether it be system calls or plugins, going through Falco, which has the rule engine that decides what to do with the event. It alerts through HTTP endpoint, the webhook, which then goes to Falcosidekick, which then takes the action on how it's going to do these notifications. Unlike writing these kind of arbitrary webhooks yourself and maintaining that, Falcosidekick was supposed to abstract away that responsibility. So then it chooses, okay, if it's going to send it for automation through those notification engines like Slack or Elasticsearch, whatever, or you can just use it for the website Sidekick UI, which we will show in this demo now in a second. So with that, we're into the demo time. I want to make sure that everyone can see this effectively, and I think it can, so that's good. So I have a simple Kubernetes cluster, and it's basically just running on one single node. And if I said kubectl get nodes -o wide, you can see the type of node it is. So it is a Linux system. It's an Amazon Linux 2 operating system is what I'm using. And I have a specific kernel version, and all this is great, So this is the environment in which we're doing the testing. So it is Kubernetes, but my node is running in AWS. So that's all you needed to know. And I've installed Falcosidekick, and you can see that they're all running as pods within my cluster. So let's do some testing. So first thing I want to do is prove that we have the connection. So look, we have a port forward. It's really small, but it's because it's not a priority here. So I'm just saying kubectl port forward, the service of Falcosidekick UI on port 2802. And again, the rest is not important for this demonstration. So once I've done the port forward, you can go to the Falcosidekick UI. And right now I have no events. There's nothing worth reporting on. It's just a pretty UI. It tells me the info output about, I'm using Redis backend and I have no password worth talking about set up on this. This is purely for demonstration and it's listening on localhost. So to show the value of it, I have two tabs here. So one that's going to show me running an insecure behavior, and the other tab here should show the output of the Falco logs that are being handled in real time, just to prove it works in real time. So I'll start by applying a file. So I'm just going to introduce a workload, a simple workload at that. And this workload, it probably shouldn't create a Falco rule that I know of, or maybe it did. Yes, it did. So you see, there's a few things going on here. I have privileged container was started. So I created this workload with, it was defined as a privileged workload. It had privilege set to true. So it had that higher level privileges on it. To prove that, I could actually just grab this YAML manifest. I could wget this file, for instance, and I could cat the file, which is dodgy. If I open here, dodgy, you can see that I had this security context of privilege set to true. So when I did that, we know it was a privileged workload, and instantly in real time, we saw a privileged workload was created, and then the privileged container had started. So already you can see we got all that deep context, but this is kind of hard to read. What would be more desirable is if I went into this UI and I refreshed my page and I go to the events view, and you can see, for instance, launch privileged container. Here's the tagging context. The description is easy to read, and you can see all the different fields are extracted in an easy to interpret way. And this is also useful in many other ways. So for instance, I quickly know that the source data for this alert is coming from system calls. It's not coming from Kubernetes audit log or some other logging service. We know the source event stream. We know, for instance, if I had a complex system of many different endpoints, knowing which host name that this is coming from is probably one of the quickest things you want to do, because you want to be able to, for instance, filter based on host name or based on other contexts. But as I mentioned earlier, I'm running this cluster as just a single node server. So it was just one node, and this is the endpoint here that we're running all the tests on. So already we've port forwarded. We can see we can easily access the Falcosidekick UI. And rather than looking as an event stream, which can be complex, we have it in the Falcosidekick UI as, a pretty to view output. So now let's look at more complex scenarios. So we created that workload. What I'd probably want to do, for instance, is terminal shell into the container. Now, we mentioned earlier that that's not a critical behavior. It's just, it's not something you should be doing all the time. You should avoid making changes. I mean, for troubleshooting, you can terminal shell into a container and check for logs within a container, or make some kind of modification if needed for troubleshooting. But generally speaking, with Kubernetes, at least, you're supposed to interact with the abstractions and kind of shift left where possible and not be making changes within runtime. So this is kind of insecure behavior we're doing here. So I terminal shell in a container, and straight away we get a new alert, and it's telling us a shell was spawned in container with the attached terminal. Again, that same output I should see here. I guess I refresh. Oh yeah, it's because I refresh every 10 seconds. So you can see the terminal shell in the container. Now, already, the more alerts that we trigger, that we show inside this UI, the more valuable this is becoming, because you'll notice that these are out-of-the-box rules. Like, I didn't even configure anything here. And because they already have this context to tell me it's MITRE, it's related to MITRE tactic ID T10610, without me even knowing how concerning this is, when I go into my dashboard view, I get a better picture of, for instance, how many of my rules align with specific MITRE attack tactics and techniques, but also where do those apply within the MITRE attack matrix? Like, for instance, these activities so far, whether it be terminal shell container or launching the privileged container, these are executions. So, so far we're only talking about MITRE execution. But if a TID came up later and it was related to data exfiltration, data destruction, these are, not just for compliance sake, these are really important for taking action, because someone is, stealing sensitive data from our organization, or potentially destroying sensitive data within our organization. So we'll jump quickly back into here. And I'm already in that container. Like I say, if I do ls, I can see I'm running as root, and I have all this, I can see all the file system of that container. If I destroy it, it's not the end of the world. It's just a test container that I'm running with root permissions. So with that, I could download, say, for instance, a MITRE package. I'm doing this just as a useful case of showing the value of our rules engine and the metadata output. So if I unzip the package that I just downloaded with curl, and I cd into that file directory, say, for instance, our rules are kind of written to handle specific activities. So if I want to do something as broad as just connecting to a, let's say, a mining pool. So like, for instance, I have the fully qualified domain and port. So if I hit enter on that, I'm running a crypto miner. Obviously, at this point, it's no point talking about the output here in the output of the logs, because it's so hard to read, because it's so big, and the more events coming through, it would just become unmanageable. So instead, I go to the events view, and I can see we got a detection for an outbound connection to a miner pool and port. But as I mentioned earlier, we need the context quickly to take action. So you can see here that we can see the full command that I executed there, which was, exmrig was the the binary I executed. We know, for instance, this was the fully qualified domain port, but also because in the output fields, I asked for specifically, I wanted to know what were the IPs they're connecting to or the range of IPs. And I also want to know what was the actual IP it connected on and what was the port. So you can see FDR IP and FDR port. So this extracting this context is so valuable. So rather than just focusing on a command was executed, I know that they connected to malicious ports and pools, for a mining pool, because again, we have a list of all these IPs, fully qualified domains and ports, and there's a rule already configured for this out of the box. But also it's extracted in a point that we know what was the context. Because for instance, if you connected to a miner pool or port, but you don't have root permissions on the exim rig, then you're going to get nothing out of it. In the same way, I don't know, we can check, for instance, if those IP ranges or fully qualified domains are actually in our block list on our firewall. So, or network policy in Kubernetes. So this is really powerful so far. But let's say they go further. They want to connect not directly to the IP or whatever, but they want to use like specific protocols that are known for crypto mining activity. So instead, I could go in here, quit this example. Sorry, I'm going to quit here. And I'm going to close this tab and just keep this one open. And I'm going to move that down a little bit. But if I was to use Stratum TCP protocol, this is a protocol specific to crypto mining activity. And alas, if I refresh the URL here, you can see, yes, it's detecting to a miner pool port activity, but also we're detecting activity using the Stratum protocol. So this is, again, by having rules in depth and being able to correlate context, like these are critical events. If someone's running crypto mining binary inside your environment, then they're naturally trying to abuse your resources for financial gain. There at no point is this, it's a bit of a warning. It's absolutely the thing that's most concerning. So you may want to use Falcosidekick for instance, doing automation based on tagging to alert better, to do automation based on the criticality of these priorities that are coming through. We don't want to, for instance, do automation based on observational activity, like, for instance, when containers are launched with privileged access, because we probably have a bunch of pods for whatever use case or testing that will use privileges. I mean, we talk about reducing the attack surface by limiting permissions on workloads, but again, this is just an observation. It's only when they abuse those privileges and start running crypto miners are we really concerned at this point. So that's one of the really good use cases there. The pod was actually killed, and that might have been due to a response engine. So we'll come back to that in a second. But if I was to exec back into the pod, it should be a clean pod at this point. Oh, the pod's gone. That's okay. So what I'll do is I'll introduce it one last time into our environment. And you can see it's now created a brand new pod. And if I exec into that pod, and what I want to do is, we talked about a while ago when we had our packages for the mining binary. At this point, I'm going to just, for the sake of it, download it, unzip it. And I don't think I even need to unzip it at this point, but we'll unzip it. And then I'm going to exit the pod. When I use this CP command, what I'm trying to do is basically say, in my pod, the way I called it dodgy pod? Well, basically, I want to say use the kubectl client. So yeah, we have in Kubernetes, it has its own CLI tool called kubectl. So I'm going to use kubectl to copy a file from a container we'll call dodgy pod. It's got this tar.gz, so the unzip package, and I'm going to move it to my local desktop, and it's going to have the same file name that's just going to be running on my local desktop. So when I copy, which should just take a second, I guess, cool. When I go back here and we refresh the URL, we can see, for instance, exfiltrating artifacts via the Kubernetes control plane. So this is so important in so many ways here. So one thing, this rule wasn't even in the stable rule set. This was coming from an incubating maturity rule set. So the Falco project's at a maturity level now that it's created the maturity framework for rules. So anything that's stable that we know it's not going to cause any false positives, it's not going to have any issues, or it doesn't require too much customization, will come out of the box and stable. Then there's rules that are in incubating that may need further work on them to make sure that they can reach that stage of stable. And then there's the other ones that are kind of sandboxed that may produce certain false positives or just require a heck of a lot of configuration. So you couldn't push them out of the box and stable because probably they'll never trigger any detections because they require end user interaction with the lists and macros to make it actually work for your environment. So the more of these activities we do, like at this point, I could, for instance, just shell into the container, right? And just perform random acts. So it might be to find AWS credentials, whether or not the directory, like the way I'm saying path to some file, the directory doesn't exist. But if I'm trying to grep something that has the name AWS secret access key, which is pretty common, even these kind of activities, if you create a macro to define what are access keys or credentials associated with AWS, well, then you're probably going to get outputs that tell you, for instance, okay, we're seeing data exfiltration for trying to find AWS credentials on a system. And this would be considered a stable rule. And again, we know this could either happen on a host or in a container, because as long as it has a file that's got those names associated with AWS, then it's going to trigger that rule. But tying it back to the MITRE attack matrix, like no matter what it is, if I'm trying to read sensitive files and if the file system doesn't necessarily exist, it doesn't have to, because the user, for instance, is going to try to perform these actions. They don't know your system inside out, but if they're trying to, for instance, run cat to read a file from Etsy Shadow, and if it has anything in it and it shows them a bunch of keys or whatever, then we should be able to go back here and say, look, even though the user wasn't successful, it doesn't matter. The user attempted to read sensitive files from an untrusted directory or something like that. So this is really powerful. So we talked about Falcosidekick abstracts us away from just looking at the raw output of the logs in the terminal to a point where we can go to this dashboard, understand what's the breakout of all of our rules based on sources, based on, is it coming from AWS audit logs, is it coming from the system call, Kubernetes audit log, wherever, but also across the tagging context. And the richer the tags you apply that are more relevant to the activity, then when we look at our rules that are being executed, we can really get a better picture of, for instance, I want to look at all MITRE execution activity, or actually I can just go to events, go to tags, and look up, for instance, T105, and then I can see all activity related to MITRE attack T1059. And if I was to look up the MITRE attack matrix, that would turn out to be related to terminal shell and container. So having all that, it's just a really powerful output. Now, I don't know where we are with time. Do we have a few more minutes, or are we nearly stuck on time?
2 minutes.
Okay, so I'm going to jump back into the slides. That demo hopefully was useful. We didn't talk through the reacting use case here, but as I mentioned, we have another session in 2 days' time, and we're going to talk about Falco Talon as a response action engine dedicated to the Falcosidekick project. So of course, without Talon, there was always the way to use all these functions as service tools like OpenFaaS or AWS Lambda on Amazon side to do this kind of automation. But the session in 2 days' time is just going to be really invaluable for this. So myself and Thomas will be back again, and we will talk about the response side of the Falco project. And I really hope you can attend, because I think it's going to be a brilliant session, and it's a really new technology and it's constantly evolving. So if there's any minute or time left for Q&A, we're more than happy to answer. Or if there's any questions outstanding there from you, Thomas, that you want to ask me.
We have 5 minutes now for Q&As.
Okay, cool. So yeah, I hope that session was useful. And yeah, like realistically speaking, there's a lot of extended use cases that we didn't have enough time to uncover today. But hopefully this was an interesting insight into Falcosidekick's capabilities.
No question from now.
Okay. I guess if there's no question, we close out. Yeah. Oh yeah, no questions coming in. Okay. Yeah, and again, if you want to contact us directly, myself and Thomas, we have right at the beginning, we put our details. I don't think we put in details, but we're on LinkedIn, we're on Slack. If you're on Kubernetes Slack already, you can contact us there. But also, I pretty much just use the same handle for everything. So whether it's be on LinkedIn or you end up looking up that handler, probably it's going to relate to a bunch of different things that you can contact me on. So yeah, thank you for attending today's session. And if there's no more questions, I'd say we're good to close out.